All right, today we're going to be discussing heat flow diagrams, and by the end of this we will be able to identify the system and surroundings in a situation, determine if a process is endothermic or exothermic, and be able to draw a complete heat flow diagram. So just a couple of reminders, when we're looking at heat, it is that energy that is moving between substances or objects, and it will always move from the warmer object to the cooler object. A heat flow diagram is used to help determine if a substance is gaining or losing energy in a situation. So we define certain things about the situation, and then it helps us determine that direction of heat flow. So one thing that we're going to have to do is be able to identify the system and surroundings. When we're looking at a scenario, the system is the object, substance, or reaction that is the focus of the scenario or situation being analyzed. In a heat flow diagram, it is placed inside of the diagram. So if we're going to have like a circle, and your system is going to be inside the circle. The surroundings are the objects or substances that are not included in the system, but exchange energy with the system directly. Typically, things like the container or other things that the system is in or on. So you can see down here is a little example. It's pretty small writing, but in this situation, the system is the water molecules, which is the water and the ice. The surroundings are everything else, like the cup and the air around it. We will also need to determine if a reaction or situation is exothermic or endothermic. A substance, object, or reaction that gains energy is called endothermic. The energy gained can be used for things like changing the state of matter, making solid a liquid, so melting, or turning a liquid to gas, which is boiling, or breaking chemical bonds. If you touch a container with an endothermic situation or reaction in it, it will feel cold because it is pulling the heat from the surroundings, kind of sucking in all the heat and using it to do one of these processes. So an example of this is if we were to take water in a beaker and add ammonium chloride solid to it, the beaker feels cold to us if we touch the side of the beaker, and that's because it's an endothermic situation. That chemical, as it dissolves, is pulling energy from its surroundings in order to help it dissolve, and so it's going to feel cold to the touch. It's going to take our heat. In an exothermic situation, so a substance, object, or reaction that loses energy is called exothermic. The energy lost can be used for things like changing the state of matter. So if you lose energy, you can change a gas into a liquid, or you can change a liquid into solid. We call gas into liquid condensing, liquid into solid, we call that freezing. Or we can form chemical bonds between substances, form new chemical bonds. If you touch a container with an exothermic situation, it will feel warm or hot to you because the energy is being given off of the reaction, so it's going to you, and you're going to be able to feel that energy, that heat. So if an example of this would be the hand warmer. We use that in our lab. When I opened the packaging, it got exposed to the air and it starts reacting, and that reaction taking place in the hand warmer is giving off heat, producing heat, and therefore is exothermic, and we can feel that heat coming off of it. So what we need to include in a heat flow diagram is we're going to have the objects or substances that are in the system. We're going to add those in. We are going to list any objects or substances in the immediate surroundings. Technically, everything in the universe is a surrounding, but we're going to narrow it down to what's next to our substance. And then we're going to label if it's endothermic or exothermic. We associate endothermic reactions and situations with being positive because you're adding energy to the system. And in exothermic situations, since it loses energy, it's negative. And we're going to be exploring that too as we do calculations next week. And we're going to add an arrow indicating the direction of energy flow. We're going to label that arrow with the positive or negative, and we're going to use the letter Q. Q actually represents the amount of heat that a substance is gaining or losing. Remember, heat is just that energy that's moving between things. So we represent it as Q. And I know that seems odd, but it's because we've used all the other letters to indicate other things. So we have Q for heat. So here are a couple of examples. So to draw a heat flow diagram, we would first just add a circle or a box, something, and the inside of it we're labeling as the system. And our first example is melting ice cream on a spoon. So our system there would be we want to put in the system the focus of the situation. Well, the thing that's changing is the ice cream. The ice cream is melting. So the ice cream is going to be our system. That's our focus. Our surroundings are going to be the spoon, and that goes on the outside. Then we are going to indicate the direction of heat flow. Because the ice cream is melting, it's gaining energy from its surroundings, so from the spoon, so the energy is going into the system. So the hotter object would be the spoon, the colder object would be the ice cream. Remember, it always goes from hot to cold. Then we would label that arrow as positive Q because that arrow indicates energy, and because it's being gained, it's positive. And because the energy is going into the system, we would label this situation as endothermic. For our second example, we're going to do our candle under the jar. So our focus of that whole situation was the candle. We made all our observations about it. We had that candle burning. So that's our system, which means the jar, the table, that sort of thing are going to be our surroundings. So you can list multiple things in both places, but we usually just keep it pretty simple with these. All right. For this one, the candle was burning and giving energy to the jar. So our arrow is going to go out of the system. So from the candle to the jar, the candle was warmer, the jar was cooler, so hot to cold, which means our energy is going to be negative. We are losing energy from the candle, giving it to the jar. So that situation is a negative energy change, which means it's exothermic. We're giving off that energy. So these are heat flow diagrams. We need to make sure we're including all of the pieces, system, surroundings, arrow, Q, and labeling endo and exo. And you've got some practice problems on this to complete. So try those out. Let me know if you have any questions. Thanks.